Today on the first Monday of April, April 3rd, we are starting Module 5. Okay, so we're doing Module 5, Lesson 1 today. And your learning goal today, by the end of the math lesson, you need to be able to, we will be exploring volume. So you need to be able to tell me what volume is, first of all. And you'll need to be able to do that by building with and counting unit cubes. So we're going to be exploring volume using lots of different strategies. And today's strategy has to do with building and counting unit cubes. Okay? So how many of you guys already know some way to find volume? Great. We're going to hold that off for right now because today the strategy we're using is building with and counting unit cubes. So even if you know how to find volume a different way or you've learned something about volume in the past, we're going to start by building with and counting unit cubes. Got it? Very good. Let's talk about the problem of the day. The first thing we're going to do is remind ourselves how to find the area of figures. In order to find the area, we have to first remember what is area. What is area? Talk to your table group. I heard lots of good discussion, but I heard one thing that I thought was a really good way to describe it. Somebody said area is the amount of space something takes up on a surface. So if I put down Drew's water bottle on the table, the area of the bottom is what shape? Circles. How much space that shape takes up. If I try to find the area of Drew's notebook, what shape is that? Rectangle. And it's how much space that rectangle takes up. Okay? And we can remind ourselves that we find area by multiplying the length times the width. Yes? Yes. So what's the area of this shape right here? 8 inches. Now, we don't measure area in inches because inches is a length. When we want to measure area, we're measuring it in what kinds of units? Square inches. So the area of this figure right here is 8 square inches. Now, let's also name the shape. So what is this shape right here? A rectangle. What shape is this one? Square. Okay, what is the area of this square?
25 square centimeters.
Very good. It's 25 square centimeters. And you can mark it like this, or you can write 25 SQ, which is short for square, centimeters. What shape is this one? Rectangle. What is the area of this rectangle?
14.
Nice. Okay. When we first shaded the boxes, what was the area that you shaded on your template? Alina? 4 what? 4 square centimeters. We know it's square centimeters because each box is 1 centimeter. Do you guys see how you shaded in 4 square centimeters right here? Then you built your first floor. And how many blocks did you use to build your first floor? 4. When you added a second floor, how many blocks did you use altogether? 8. And then when you built your third floor, how many blocks were there altogether in your structure? 12. So in this last solid that you made, the one you have standing right now, there are 12 blocks, yes? Okay. So the first vocabulary word is a unit cube. A unit cube is what you have in front of you. One of these is a unit cube because each dimension is exactly 1 unit. So here, from here to here, oops, that's not what I want. From here to here is 1 unit. The length is 1. The height is 1. And the width, which is this way, is 1. Okay, so a unit cube is a cube in which all 3 lengths, the length, the width, and the height are exactly 1 unit. And in this case, what is the 1 unit? 1 centimeter. So what you have in front of you, each cube, is a unit centimeter cube. Okay. A cubic centimeter is the amount of space that 1 cube takes up. Just like how when you colored in 1 box on your centimeter paper, that was a square unit, a cubic centimeter or a cubic unit is 1 centimeter each way. Does that make sense? And we can write this using centimeters cubed, like that. So we measure volume using cubic centimeters because volume has 3 dimensions. Your solid takes up a certain amount of length, a certain amount of width, and a certain amount of height. So because there are 3 different dimensions, otherwise known as 3D, right, 3 dimensions, we measure it using cubic units. And in this case, we're using centimeters as our unit. So therefore, when you count the number of cubes your solid takes up, and if you're using your cubes correctly, you should still have a 3-story structure. The amount of space it takes up in 3 dimensions is called the volume. Okay, So what is the volume of the structure you just built? 12 what? Yeah, and we measure volume using cubic units, and in this case we're measuring using centimeters. So the volume of the figure you just built, the solid you just built, is 12 cubic centimeters. Oftentimes when we're talking about volume, actually all the time when we're talking about volume, are we talking about 2D figures or 3D figures?
3D figures.
Okay. One thing I really like about this math book that our old math book did not do is it actually teaches you how to draw 3D figures. Some of us have really good knowledge about how to draw it, some of us don't. Today, all of us are going to have good knowledge about how to draw 3D figures. So, what I want you to do is take the blocks and push them off of your template paper. Thank you. Now you're going to turn your template paper 2 times until you see what it's this dot paper. Okay? Here's what you're going to do. You're going to watch me as I demonstrate step by step, then you're going to get a chance to try. I want you to watch me first because it'll give you a better idea of what to do. Those of you who are already drawing, you are not watching me first. In fact, let's put our pencils down and put our hands on our heads. Thank you. Okay, step 1, you're going to connect 4 dots to make a parallelogram. Okay? Do you see how they did that? They found 4 dots and they connected it to make a parallelogram. I can do that here too. I'm going to find 4 dots and I'm going to connect it to make a parallelogram. Do you see that? Mm-hmm. This represents one square face of the cube. Even though it doesn't look like a square, it looks like a parallelogram. When it becomes a 3D cube, it will represent one square face of the cube, viewed at an angle. You're looking at it from the corner, not straight on. Does that make sense? Mm-hmm. Step 2, you're going to draw 3 straight segments to the right of the 2 vertices. Okay, so vertices are corners. So here are the top 2 vertices. You see that? So you're going to draw straight lines, not like that, okay? You're going to draw them like this. Do you see that? And then also the vertice on the bottom right, like that. Okay? Now those are the lengths, or the widths, however you want to classify it. Step 3, you're going to draw 2 segments to connect the missing edges. Okay? This time, I'm going to show you how to draw 2 cubes stuck together. Okay, so you're going to connect 4 dots to make a parallelogram. This time, instead of drawing, okay, see, this is just like the beginning of what I was doing before, right, to draw 1 cube. This time, I'm going to add another parallelogram that shares this first edge, just like my cubes. See how when I have 2 cubes stuck together, I'm going to draw another one. So here's the other front face of the cube. Do you see that? Okay. Then I'm going to draw 4 straight segments to the right from the 3 vertices on the top and the one on the bottom right. So just like before, I'm going to now draw these ones. But this time I have more. Do you see how because I have 2 cubes, I have to draw 3 lines instead of 2? Okay. And then I'm going to also draw the one on the bottom. See that? Then, just like before, all I need to do is connect the missing segments. And do you see how now I have 2 3D cubes stuck together? I could do the same thing if I have 3 cubes in a line, couldn't I? I could draw 1 parallelogram, 2 parallelograms, and 3 parallelograms. And then I would draw lines to the right on the vertices like that. I'm getting a little sloppy. And then I would draw the missing edges. Do you see how now I have 3 cubes stuck together? Okay, take a moment right now and practice drawing cubes that are stuck together in a straight line. Go. Now that we've thought a little bit more about centimeter cubes, we can see that Ron is correct because both figures have the same volume of what? 12 cubic centimeters.